So should I start now?
Yes.
Yeah, okay. I'll share my screen. Am I audible enough? Is this
Yes.
okay? Is my screen visible?
Yes.
What are you seeing? Could you please tell?
Google Meet screen.
Okay. Now,
It is still the same.
okay, now.
It has come to Jupyter Notebook. You can increase the size.
Yeah, okay. Just a moment.
While presenting, you select the tab. So that will be faster. You can
Yeah, now is it
switch over
visible?
to the tab.
Yeah,
It is
is it
Google
visible
Meet.
now?
You can switch over to the tab and select that tab.
Uh,
Yes, it is visible now.
I have actually. Okay. Yeah. So today we will try some of the Excel assignments that you had in Python. So, sir, should I start with the day 3 assignment, the Gaussian distribution function?
Yes, you can start with that.
Yeah. So I'll just, for simplicity, I'll copy the question here so that we can see. I have already written it. Yeah. So we had to integrate over this. Integrate over this function using the Simpsons 1/3 rule. So this is the equation for the Simpsons 1/3 rule. Uh, the key thing to notice here is that you add first and last terms just like that, like you did in Excel, and the 4 times fi will be only for the odd numbers and 2 times fi for even numbers. So here you'll have to put Excel's condition to check for even or odd numbers. So yeah, so we'll start writing the program. You can follow with me. So import numpy first. And we will define our nx function first. So for now, we'll ignore the constant a because in integral it will anyways come out. We'll just see exponential to the power minus x square by 2.
What you can do is you can define that
So I'll
integral.
define a
You
function.
can keep a equal to 1 and later change that constant.
Okay. So we'll define a function which takes x as a parameter over a range. We'll add the range later. And what it will return is exponential of, which is the power function from numpy, which is x square. Alternatively, you can also use minus x star star 2 and divided by 2. Sorry. Yeah. So this is our function. Now we'll define one more function which is this Simpson's rule. So what are the parameters that we need here? We will need a and b, which are our lower and upper limits, and we will need the number of intervals that we are dividing into to find h. So we'll define Simpsons 1, 3, which takes lower limit, upper limit, and the number of intervals. Then h is given by the upper limit minus lower limit. So upper limit minus lower limit by 2, by n, I mean, sorry, by n. This is the width of our one interval. Then we'll define an empty list where we'll store our x's. We can also define it as list and open bracket. It's the same thing. Then we'll define our function, which is the nx. We'll append our values into this, and let's initialize I as 0 to begin.
Whatever changes
Now
you are
what it will do
doing,
is while
no, it's not visible. Okay.
sorry, I couldn't understand what you said.
The
Look
screen
up.
did not get a refresh.
Yeah,
but-
yeah.
Okay, now is it visible?
Yes, we are seeing while.
Okay, yeah, I'm there. I'm on that step only. So while I is less than or equal to the number of intervals that we have defined, what it will do is it will append the x value, so which will be our lower limit plus now I into h is our width of the interval, which will keep on increasing as we go to the next iteration. So lower limit plus I into h. For I equals to 0, it's just the first interval h. For next interval, it becomes 2h, 3h, 4h, and so on. So that gives you x, and then we can add an x append. And in x, we can call our function which we had defined. In our function, we will put x I. So x0, x1, x2, it will just keep on adding into the nx list. And now while n is less than or equal to n, so we'll have to increment I in the while loop. So this will go to the next I, and until that is less than n, it will keep on going. So now we have the values of nx. Now we'll initialize one capital I, which is our value for our integral. We'll again say I0 and we'll use while loop again. So while I is less than or equal to n again. Now what we have to do is we have to check for the even and odd conditions for the third and fourth terms. So if I is 0 or I is n, which are our first or last terms, then our integral value will just add the next term. Else if I percentage 2 is not equal to 0. So what not equals to 0 means that if I is odd, for odd condition we need to take 4 times of fx. So I equals to 4 times of nx, whatever the ith index will be. Else if I is even, that is equal to 0, if divided by 2 is equal to 0, then we have to add 2 times a value. And then for all this, we have to increment I because we're in a while loop. And now this h by 3 factor, this is remaining. So whatever I we have calculated is this bracket part till now. So now we'll just update the value of I. So I equals to h by 3 into the I that we have calculated till now. So yeah, this is the integral value that we have. I can test this by running once. Don't have any error. So now to find the integral value, we'll just call the function Simpson 13.
Do you have to return this?
Sorry?
Do you have to return this Simpson 13?
Oh, yeah, I have to. So return I. So Simpson 13 will call with our question asks for the in range -10 to +10, and our intervals given no. Then we'll take about 1000 or we'll take 1000 intervals. So from -10 to 10, and if we take 1000 intervals, is it not printing?
Try printing your.
Yeah, in the function itself, right? Print I. So yeah, we get this result, 2.5066. So if you integrate it on a calculator, you can try it, because this, if you try to integrate this manually, it's difficult. It's a Gaussian error function, so it's a special function. And you get up to, I think, this decimal, you get same value in your calculator. Now, if we increase the number of intervals, our accuracy will increase. So yeah. Now to find A, what we'll have to do is we'll have to do the inverse of I. Now we have the integral value. So the constant A we have defined 1 already. So yeah, this is the first problem that you had. You can make this fancy by adding statements like for lower limit and upper limit within intervals. You get this value. You can print the formatted statement. You can do the decoration there. But
It is
now
not
we'll move to.
refreshed. The screen is not
Sorry.
refreshed. Okay, fine.
So the last time,
Now,
like, I is equal to h by 3 into I, shouldn't it be into sum of I?
okay, it shouldn't be sum of I, because what is happening is we are not putting I as a list. So we have initialized I equals to 0 here. And while every time it checks the index, if I is 0 or n, it will just add the ith index of nx to I. So I keeps on updating while the while loop is running. So after the while loop finishes, the I, you end up with I which is not multiplied by h by 3. So you just update the value by multiplying by h by 3 into I.
What is also possible as that in the upper loop where you are appending nx, there itself you can decide the condition and multiply this function with 2 or 4, so that nx will
Okay.
give you all Simpson terms. No, not there, not there.
No, I got what you said, and I had tried it, I think, but I still kept it like this because it was easier for me
No,
to
this is simpler. This is simpler. But if somebody wants to, if you want to
we
build
can
a
try.
template
Yeah.
for Simpson rule, then you may do something like that. And then that
So if
template itself can be, that function itself can be used wherever you want to do integral by Simpson rule.
yeah, so let me see if this will work. Append nx, and if okay, let's try.
Append should happen. Okay.
Okay, it works. It became shorter now. So what we can do is, if we, instead of printing, we say return I. Now what will happen is, whenever you will call this function, you will be returned with this value. So if you want to use now this predefined function in some of your other programs, if you're plotting some
So you
graph
can
and
write here print Simpson 13.
yeah, so that will print the value. I'll just delete this cell and run this again. Yeah, so printing will return the value. If I just say print here, I need to only call the function. But if I say return, then I need to print the function. And now returning, what is the benefit of returning is you can use this function in any of your further programs if you want to find area under any function. So shall
Hello,
we
sir.
move to the next? Yeah.
It's showing some error. It's saying that n is not defined.
Which n are you talking about? Small n?
Small n, yes.
So small n is your third parameter when you call the function. Have you put that parameter?
Yes, sir.
What is the number you have put?
I 10,000.
Is the spelling correct and brackets correct while calling the function?
Simpsons 13. Yes, sir. It's showing that name error. Name n is not defined.
Do
That
one
should not
thing,
happen.
post your doubt on WhatsApp. I'll
Yeah,
help
you
you.
can post a picture with your program and the
Okay,
error.
sir.
Yes. Show full image of your the
Hello, sir.
function you defined.
Sir,
Hello,
Okay,
sir.
sir.
sir,
Yeah.
it's showing invalid syntax when I typed elif I percentage to exclamation equals to 0.
Have you put this colon?
Yes.
I percentage to not equal to 0. Check this if you have typed it correctly. There should be space between elif and your condition.
Yes, it is exactly similar.
So it may
Okay,
be
then
one or two lines above your code. You may miss something there, and it will show you invalid syntax in the next line. Try checking the above lines.
Sir, sorry, I missed your word. Sorry.
Oh, I just informed that you may try checking other lines above it.
see if the indentations are correct.
Oh, okay, sir. Yes.
Even that can give it syntax error.
That is the
Sir,
problem. Right.
Yeah.
hello, sir.
Is there any other question?
Yes, sir. Here
Yeah.
you have defined like one function in another function. Like here you have used that function. Like you can do that all the time.
Okay.
Like first you like name define the function func of x, and
Yeah.
then you have used that in the Simpson function
Yeah.
for appending.
Yeah, exactly.
Okay.
So that is the
So
benefit of using the function. So now what I have did here is, instead I could have typed this whole thing inside the append. But to shorten the code, I'll just define the function first only, because I'm going to use it a lot in my further steps. So now
to
what I
this
can do is, see, I have defined this function. Let's say this is function 1. I can define another function. So function 2 of x, and I'll return some other function. So let's say this is, now this was minus x square by 2. Let's say I'll just define x square by 2. So positive x square by 2. So now this is function 2.
meaning that
This is
the
function
Simpson
1.
function that you have defined here will only return for the Gaussian function unless and until it is also defined for another function. So we cannot
Yeah,
use this
exactly.
Simpson function for another kind of integration of other
You
kind
can
of.
use it, but when you append this function here, you need to define which function you want to integrate. So you need to write, see, I am defining this one more function 2. So this function is e to the power x square by 2, positive x square by 2. Here it was negative x square by 2. So I'm defining
Okay.
function 2, and now to integrate this function, I'll have to put function 2xi.
So cannot we like take as a function also one of the parameter in that definition of some Simpson function, like with LUN
Here
and the
itself,
type of function? Yes. So
yeah, you
we
can
can
do that
use
too.
for any kind of function.
Yeah, you can do that too. You could try doing that.
So we just type like we have to define the function in the loop after the in the like
Yeah, you have to
definition
put it
of
here.
function.
This is the important step. This will append your function values to nx list. Nx
Okay.
is just f of x. Well, I have used nx because here it is in the question, it is defined n of x.
Sir, so
Yeah,
when I'm printing this Simpson 1.3, so it is showing me that list object has no attribute append.
have you defined the lists properly, x and nx?
Yes, sir. Yes, sir.
Spelling of append,
Yes, sir.
round brackets of append. Check the syntax properly.
Okay, sir.
So we'll move next because we have to cover many questions later. We have to cover at least the second and the third assignment. So I'll just move forward. So our second question was about Stephen's constant, the Stephen's law. I'll just copy the question so we can see it here. So this was our amount of energy radiated per unit area. This was given. So let's start writing the program right away. We'll import the libraries which we require first. So this scipy.constants which I'm using, we have not told you about the scipy library, but what you can do is you can just from this library from scipy.constants, you can import all the constants which you want, like Planck's constant, speed of light, Boltzmann constant, and the pi value we will need. So now we can just directly use these keywords in our function and it will identify it as constants. So when you do this, remember that you don't use these variables to define other things. So h, c, k, and pi are now already used. So let's get our values for frequencies. So np dot linspace, we get linearly spaced values from, in our question it is I think 1e12 to 1e16. So 10 to the power 16 hertz. Will take about 10,000 values. And our temperature values we have 2800 and I think 5800 in your Excel assignment. So for now, we'll define this function like we had defined before because we're going to use this. So let's define the function named energy radiated.
You
And
can
it will
use, you
accept
can,
the
in fact, you can call this function itself as FUNC, I mean, whatever you called earlier. So Simpson can be directly called.
Okay, we can do that too.
But sir, there was only one variable x. Here there are two variables.
So that would, but the
So
energy value
that is
which will
for
be returned,
energy
that is for one
variable.
value, right?
Sir,
This function returns one value.
I think in question 2 we have to use that trapezoidal formula for
Yeah,
it.
that's why I was thinking we have to use
So
trapezoidal formula. So should I just use
What you
Simpsons?
can do first is you use Simpson rule and get the answer.
Okay.
Trapezoidal rule can be modified later. you can define that
Okay.
function separately.
Yeah, okay, fine. So we'll define our energy function first. So this will return our energy, which is 8 into 8 pi h v cube. I mean mu cube. So this divided by, we have c cube divided by, we have np dot exponential h nu by kt minus 1. So this h nu by kt is inside the bracket. So h nu by kt minus 1. So we have this function. We defined energy now. Now what we'll do is we'll define an empty list. But we'll need multiple lists because we have multiple temperatures. So we'll define same number of empty lists as many temperatures we have. So for y equals to empty list for I in range length of t. So what this will do is it will make same number of empty lists as many values of temperature you have put. Now for I in range,
Now there is one confusion can happen.
okay.
In the function energy, you have used t, which is a local variable for that function. So you may call that as TMP or something like that. And then when
That
you are
won't
calling
matter
function, that you
because
may write T0 or T1.
no, that won't matter because while calling function, whatever will be in the second index, it will take that as a value. Whatever you put here,
Correct.
it won't
So
matter.
what I'm saying is, you can call this TMP, right? And
Yeah,
here inside the function, so as a local variable, you can define it separately. And while calling, you put T0 or T1.
yeah, okay. So for I in range, length of t, and for j in range, length of v, or whatever the frequencies we'll have. What this will do is it will append to the index
Same
of
for
yi.
frequencies. Same for in the energy V, you may write F. Local variable.
Okay, okay. Actually, this will create confusion, sir, because then we'll use v later and we'll say, okay, but
This will
it won't matter.
not, I mean, this will create confusion for some surely, but here basically we have to understand that F and temperature are the inputs this energy function needs, and they will be written by this expression. So
Okay.
because in this case, F and T or that V and T are single variables, whereas outside the loop, they are arrays.
Yeah.
So to avoid that confusion, I said make this.
Sir. Sir.
Yes.
Hello.
Yes.
Yeah. See.
For I in range is missing. In is missing, I think.
Oh yeah. Thanks. So now what this will do is for I in range length of t, whatever be the number of elements in t and whatever be the number of elements in v, that is our frequency. What this will do is for I equals to 0, that is for our first temperature 2800, it will append into the list y of 0, which is the first list. It will append values of energies and it will keep on incrementing the frequency because v of j, and this
So
is our
all
first parameter,
frequencies.
which is the frequency.
So for lower temperature, first all frequencies will be calculated.
Yeah.
I mean all energies for all frequencies.
And this will be t of 0. So t of 0 is 2800. Then when the j loop is completed, for all of the j values, y of 0 is calculated. This will go to 1, and then for y of 1, it will calculate again, putting all the values of frequency. So now we have two lists inside y. Y of 0 is the list containing all the values of temperature and the second list has values of energy at temperature 500. Now we have done that, and
To
then
make it
we'll
clear,
convert it into arrays. Yeah.
Sati, to make it clear,
Yeah.
to realize which loop is being run, after for I, you may add one statement, say print ti or something like that.
I can just print I.
Or ti also.
Okay, you want the value of temperature.
I mean, because it is going to be run only twice, that will just
Yeah, okay.
help people realize that now it has calculated for t, now it has run the loop for next t.
Yeah. Now for plotting, we'll convert these into arrays. Now we have converted into arrays and we'll proceed with plotting. What this does is it converts it into arrays so that matplotlib won't have any problem. So let's say figure. Now we have to plot for all the temperature values again, right? So we'll put our plot also in a loop. So for I in range, again length of t for all of the temperatures. We'll plot the x array, which are our frequencies, and we'll plot the y array, and we'll put index number in this. So what this will do is for first temperature, it will plot first y array. For second temperature, it will plot the second y array. So let's just test this much first. So yeah, we got the curves. Now what has happened is the x limit is very huge. So let's go back and put some limits on that. So we need x limit for this. So we'll go from 1e12 and where is it going? Okay, we can plot till 2 or 3 e15. So let's go to. Let's see how it
How
works
do you
out.
know that it is going from 1e12 to 1e15?
How do we know what?
That the frequency values plotted are from 1e12 to 1e15 or 1e16.
Because
Because
we
you
have
don't get
plotted
that
x
on the.
array. We have plotted frequencies which we have defined start from 1e12. So we know for
Yes,
sure that
but it is not shown on the label.
it is shown 1e16, right? So 1e12 is very small here, like it won't be even
Fine.
visible. So what we can do is we can say here that x limit is from 1e12 to 2e15. Now it will show like this. So 1e12 is somewhere here exactly. It will start from there. And this is 2e15. So we get this plot. And then we can go into
Then
cosmetics.
you could
Sorry. Was there some doubt?
no, you could start it a little before 1e12. Then it won't look like it is crashing.
Okay. So we should not change power. I'll just go 0.18. It is the same thing. Fine. Let's see. I think it will plot the same for the reason that we have defined linearly spaced functions starting from 1e12. So all our energy values are also starting from that. So it is starting from 0.
I see. Okay.
We can try changing this to
Sir,
111 and then maybe something. Yeah, was there any other doubt?
It is 1,000 parts. So anyway, whether you go even smaller, it is not going to get affected. If you
Yeah,
plot, say it up to 10 to 13, then we'll see the effect.
up to 10 raised to 13.
Yeah. And then you plot from,
Oh, it just started rising here.
okay, so then you start from value below 0.5 10 to 12. Are you making changes?
Yeah, is it not visible?
Or
So yeah,
not
this
getting
is till
refresh?
14. Oh,
Yes,
hello.
we can see. Yes, yes.
Am I audible? I think my
sir, your screen is lagging somewhat.
You're audible. It's just that the graph came later.
okay. So shall I move to the next thing? Now we had to find area under the curve. I need to rush a bit because else we won't be able to finish. So you can do some decorations here. You can add grade, legend, and everything. You can play with that later. Now what we will do is, sir, we had to call our Simpsons function,
Yes,
right, which
you
we
have
have
to
defined.
do the integral.
Simpsons 13. Simpson 13. Whatever limits 1e, 12n, and 16 in 10,000 intervals. But sir, we have to we have not called this function inside that Simpsons definition
Yes,
yet.
inside you have to call this function.
I'll have to define it again or add as an argument here.
No, you don't. Simpson 13, inside Simpson 13, you will have to define that function, right?
Okay, I'll copy paste this. So what we have defined here is energy. So this will be energy, F and temperature. Vj and Ti.
It will be x of I.
I don't think we can put temperature, like we'll have to put one temperature value here.
You can put T0, T1.
No, but I is less than equal to n, right? And n, this will work because even we have, I think, 10,000 values, so that will be fine.
No, but why are you defining it here this way?
How else will it append the
Here
function?
you have to, here it will take the return value of energy.
Yeah,
We have
that's what we want,
abundance
right? We
of.
So
want area under
you
the
are
curve.
calling energy.
I'm calling energy over all of its frequency ranges and at temperature 2800. So what effectively this will return, this should return is area under this blue curve.
So you have to do it double. Okay,
Yeah, I'll have
first for
to do it
2800.
twice. First for
First for
2800 and then
2800, then
yeah.
for okay.
Index error 10,000 out of bounds for axis.
But you see, wait. You are making a see the intervals in Simpson rule have nothing to do with intervals in Planck. No.
No. What this will do is will append energy value for each frequency value and temperature value into nx. So we have nx list full of energy values at each of these intervals temperature, v intervals. So I'm not sure why upper limit lower limit is okay, lower and upper.
So,
Yeah.
where you have written energy V of I, we can also write X now, because in X we have taken lower limit and we are increasing it with the step size. So X also contains the frequency.
No, X won't contain frequencies. X is an empty list, and it is just
No, but
adding
you're
1, 2, 3, 4, 5 values.
okay.
Whereas our frequency values start from 1E12
The
to 1.
frequency should be L plus I into this H.
So that we have appended in X. No.
So the next and next frequency will be taken, right? Yeah.
Okay. I think I get what she's saying. So V of X should also work by that logic.
Yeah,
Sorry,
that
X of
only
I.
I'm saying.
Yeah.
Yeah. X of I will work because we have appended, we are increasing the frequency.
Okay, but X is appended. In X we are putting. Oh, okay. Let me try. So Xi should work. Yeah. Okay. So this is almost close to the value what I got when I use trapezoidal rule for 2800.
And this is the total amount of energy, right?
Yeah, this is the total amount of energy in this range.
Total area under the curve
Area under the curve.
2800.
Yeah.
Okay, and you calculate for 5800, and then both these values should be divided by t raised to 4 to get, and multiply with c by 4 to get C1 constant.
Okay. We'll do one by one. So first for 2800, now we have got this area value. So what we have to do is into t raised to 4, right?
Divide by t raised to 4. It c by 4.
Okay, so we have to print Simpson 13 1e 12 to 1e 16 10,000 divided by
You have taken only
2800
1000.
to the power 4. Simpsons
Power 4.
13 1e 12
Power
1e
4
16 power 4. So what this
into c
is,
by 4.
this will give that constant, right? We have to multiply this whole thing by c by 4.
Yes.
So c by 4 into Simpson this. So this should give Stephen's constant now. Yeah, it is close enough.
It's not refreshing. Okay, yeah, right.
This I think up to second place it is correct. 5.67.
Right.
So yeah. Now you can put this in loop and do for all the temperatures again, and you can
So
also try writing.
just copy the same function and put 5800. I think that should work. See in
We can-
print. No, not that, not that, not that.
we have
Okay,
to
you
give
will
the
have to
string.
write 5800 there.
Yeah. Or what we can do is we can redefine the function and take t as an argument here.
Yeah, that is better.
So let's say we take capital T. Now we should say here t, and we should use here 2800. That's it, right? Everything should say the same. Here 2800. Let's try. Yeah. Now we can just call this function again and for 5800. For this, we should get the same value again, a constant for 500. Huh.
Divide by 5800.
Something is. Oh,
Divide by
yeah,
5800.
yeah, yeah. Pretty close. Up to at least fourth decimal we have seen. Fifth decimal.
Yes, good.
So yeah, this is the second thing. Now, should
Now,
we go to
just
the
wait
third?
whether people have any doubts in
Yeah,
this,
if you have any doubts in
if
this.
they are parallelly working and are they getting any difficulties.
Is everything clear up to here?
Sir, can you please show the code of that energy function that we defined earlier?
Yeah. So this is the energy function.
The screen is there. Okay. Okay, sir. Thank you.
Yeah. So should we move forward? We can actually use the same function for the next part. For invisible range, we have to just change these limits, right? So we can calculate area under the curve, under the visible limits, and find the ratio. Let's try that. So for visible range, we have frequencies from 4E14 to I think it is 8014. I don't 8 or 6. Sir, can you confirm 8014 or what we have taken in question?
Yes.
In 84.
Yeah, we'll take again 10,000 and for temperature, say 2800. So what this should give is area under the curve for temperature 2800 is within the visible frequency range.
Now what you can do is you can divide this. You can divide. You can straight away write to Simpson 13 for this range divided by Simpson 13 for the larger range.
Okay. So print Simpson 13 for visible range divided by Simpsons 13 for this whole range. So it'll give you the ratio of visible to area under entire region. So this is the efficiency.
Yeah. So that is 0.08, which means what is basically it is showing is in the visible range you get only 8% of the energy in the
Visible
in the
region.
light form out of total amount of energy emitted by a body at 2800 Kelvin. Typically
Yeah.
a filament lamp, just 8% energy comes into visible region.
We can try for higher temperature, which is the surface temperature
5
of sun almost.
500, just change
Yeah.
that.
So for 500 temperature, what we get efficiency percentage is 44%.
Yeah. So sunlight gives you much larger amount of energy in visible.
So yeah, that this was much faster way using the Simpson 1-3 function itself, because trapezoidal would have taken long to write.
So Jay has
So we
written
have
one error.
completed.
You can check the
Sorry,
chat. Jay has written some error.
unsupported operand type for star. Try putting the Simpson 1-3 in bracket, like bracket Simpson 1-3 and other things. Also, you need to close bracket here at 2800.
No,
Close
see,
bracket in
see,
Remove,
Simpson
yes,
1-3.
close at
remove,
print and multiplying that with Simpson.
just remove one closed
Oh yeah,
bracket
this
after
this
C by
whole.
4.
I'll
Should I
just
remove that
put in
C
chat
by
box.
two
Correct
brackets?
it.
No, no, no. What you have done is print C by 4 and you are multiplying Simpson with print function.
Okay. I got it. Okay. Unexpected POF while parsing.
Yeah, I have corrected the syntax and put in chat box. You can try copy pasting that.
Okay.
Yeah. So,
Did not complete
sir,
another
should I
print
plot?
statement. Actually, you have to, one has to realize now, see that the precedence rule, you don't need to put bracket around C by 4. Okay, you just say print C divided by 4 multiplied by Simpson 1-3 function.
Yeah. Sir, should I show them how to highlight the visible region in our
Yes, yes,
plot?
please do that.
This plot. Okay, so now what we have to do is, see, our visible region lies somewhere from here to here only this much part. What we can do in this plot is we can highlight that much section to visually show where the region lies. So for that, what we'll have to do is we'll have to find out at what index of frequency do our visible frequency starts. So for that, we can write for loop for I in range length of v. What this will do is, if v of I, okay, we have to define our ranges first. Say the low range of visible region is 4e 14 and high range is 80 14. If if the index is equal to the low range, that will be our starting index. Else if the vi is equal to our high range value, then that is our end index. Now we can print and see what we get with
What is
this.
the guarantee that low range and high range will lie in VI?
Sorry, I didn't understand.
What is the guarantee that this low range value that you are giving
Mm-hmm.
is available in VI?
Okay, if we give values which are not present in the v itself,
Right.
then we'll write one more else and say values are out of bound.
No, no, no. Can you pick up a value very close to that? That is what I'm asking. See, that exact number may not be present in VI. So say, can you do something like this, that when I is between this number and that number, something like that. See, low range and high range, you have defined fixed two numbers. And when you called vi, when you made that vi as a list, okay, by appending, you had some numbers decided by what is the value of dn.
Oh, okay. Oh, so I got it. So we can say less than or equal to.
Okay.
So if vi, which is our start index, it should be greater than or less than. It should be greater than or equal to low range, right? So our start index should
That's
be
right. Yeah.
greater than low range or equal to low range. So whatever will put low range, if this number is not present, then it will take whatever the next number available is. And our high range should be less than or equal to high range. So then that will give us the index number of our the lower and higher ranges. Is that okay?
Yes, that is fine.
Okay, so we'll also print the index here. So start is at I, and end is at let's see where it lies. So oh,
Wait, so every value of I which is lower than the lower range, it will assign that as low start index. So it shouldn't be greater than equal to low range, as well as in that vi is less than equal to high range.
You will have to put else statement.
here.
No. If vi is greater than low range, then you are doing this. Else if vi is less than or equal to high range, but then no, you have to check both the conditions. No,
Yeah, I don't think we'll have to put equal to only. We are
not
comparing the
not equal
values.
to, not equal to.
Let's try that. Now that we are
Wait,
getting
wait,
these
wait.
indices.
What I think is the first condition was correct, less than equal to. But suppose that is not getting satisfied, then it will check for vi greater than equal to high range.
No, it should get satisfied, right? We need some low range. We have said that that will be our
So
start
vi
index
has to be
assigned.
greater than equal to low range. And else if less than equal to high range.
That's what I had did. What this will do is it will print all the index values which are higher than low range for start index, and all the index values which are less than high range for end index.
Correct.
But we need only two values for start index and end index. So we need exact number.
No, not exact number.
With
You
see,
can
if
break,
I
na?
run,
You
if
can
I
break.
run this,
You can go to the next. No, break and go to the next.
I'm not getting. In our v function, we have anyways taken 10,000 values. So that is 10 raised to 4. So increment is in 1, which is, so they're very close. So whatever we will
So,
put, I think,
You
yeah,
can define a new variable and assign that to I.
so
yeah.
we can also specify like particular dn, and then we can check if vi minus low range, or if it lies in that dn value, then we will append it. Otherwise, we'll ignore it.
So our error margin, you are saying.
Yeah, whatever we want in a certain limit of low range. Na? We don't want all the values which are greater
Wait,
than low range.
Pratik, you may try doing this. check the okay, yeah, vi square minus low range square. Oh wait, vi minus low range the whole square should be a very minimum number. Then you can assign start index as I. So
Could you what should I
so
do
I
change here?
put vi in brackets along with low range.
Say Vi minus low range.
Huh.
Okay, so
And then
vi
yeah,
minus low range
yeah, and then square the bracket
square.
and say if this value is say less than some 0.001,
Basically 1 E minus 8. No, 1, whatever it is, 1.
this value will depend on the iterations. So whatever iterations you have done with v, you can do similar thing for uh, the 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 distance. I mean, should be greater than say, for example, you just type 0.001 for now. See what you get. And similar thing for this thing. Huh?
For high range, it should be opposite now, or otherwise absolute value you have to take.
Uh,
Yeah, let's see if this works. Okay,
yeah.
yeah, this works too. Okay, cool. So now this is more
Actually,
generalized.
squaring doesn't make a difference. Squaring would have taken care.
Just this would be fine.
But I think that dn itself is very, very large. You are starting with 10 raised to 12, and if you take even 10,000 terms, that is still going to be 10 raised to 8. 10 raised to 8, I am seeing.
But then this is a very huge number.
Yeah, but your dn is also very huge number.
Sir, the
No, I don't.
1e8 represents I mean, the value of the frequency, the difference between the value of the
Okay,
frequencies.
I got what you are saying.
Yeah, this is the error which is acceptable between these two values.
So now can we check for the values which are not in the range and see what happens?
So something is not working here. What should I
Square, you have
change?
removed the
Square.
square.
Yeah. So how will we know what value is not there in the list?
Like something we can change the value.
2 point, we can take decimals more like that. 4.332, 6.22 like that.
To change the
Yeah.
v no, because these values are there in the v.
Yeah. So see the index
No,
changed.
what she's what she's trying to say is just keep a low range or high range which is not inside that V array.
Ah, 111 outside of
Yes,
the bounds
something
of
like
V
this.
array,
Yeah.
and only 17. So it should take the. Okay, it will take some. It didn't print any of it.
You can just say one more, like add
Yeah.
one
See,
more
so
else.
if I say 12, then its start index is 1 and end index is out of bound. So if I have to put else statement then. don't think it. Yeah.
Break.
Else break should I write?
No,
Or
huh.
after this? Oh, okay. What if I put this value 11 and both of them out of bounds and etc. Okay, now this is more generalized. Should give first and last. Okay, so we should not waste more time on this. I'll just what was our values? 80. I forgot. 80 14.
Yeah, 40, 14, and 8.
Why is it again out of bound?
Oh, for the very first value, it is not satisfying. So it goes to else and breaks.
It is satisfying. Lower range is
No. Like if just remove the else statement.
okay. Now we got. Okay, we'll have to discover this more, how to make it general. We'll just move forward. We don't have enough time for this. So what were we doing? I forgot.
Plotting.
You wanted to highlight this region.
Yes, okay. So now that we have our indexes, we can just actually, can I just copy paste that code? This is same, right? And to highlight, what we will do is, so we'll use the function axv_span. So x is vertical span, this stands for. So it highlights vertical section. And we have to put our limits. That is, on x-axis we have lower range limit and high range limit. And we can specify the color, let's say green. And alpha is the saturation of the color. I'm not sure if I'm using the correct terminology, but higher alpha number will make the green color more darker.
It's more like transparency.
Okay, more like transparency, yeah. So let's see. Okay, it's barely visible. Is this visible?
Yes.
If we say 0.5, then it will go very dark. So this much region is our visible region, and the ratios that we calculated above, this ratio and this ratio. So it is area under the curve only for this highlighted region divided by the whole region under this curve, and this region, this much, divided by whole area under curve under yellow line. So that is just this one line. That is how you highlight the sections. Now, if you put, I think, Jigar, could you confirm if we want a horizontal? Is it AXH span?
I'm not sure.
I think that is how it follows. If AXV is vertical, then AXH should be horizontal. You could check that later. So yeah, this is it about. You can add here X label, Y label, X legends, and title and decorate yourself. That is a good practice. So this is the end of your assignment 3, I think, in Excel. So should I go to the Maxwell velocity distribution
You can
thing?
convert this function into Maxwell and plot.
Yeah, so I write a new function Maxwell. So I'll copy paste the question so that we can see here. So yeah, our Maxwell function will take values of u, our mass, and
And
the
T.
temperature. It should return.
F3.
First
Yeah.
is 2 by to the power half, so 0.5. Multiplied by m by k by t to the power 1.5, and u square into u square into p dot exponential of minus m into u square divided by 2 k t. Okay, all the terms here now. U square exponential of this bracket complete. Okay, yeah, this should work. Let's test the function by taking some values.
Now do
So
one thing.
yeah.
M you can convert within this function into from AMU to KG also.
Within
So,
this function itself.
you only have to give atomic mass.
Yeah, I will give the mass in kg.
No. Say within the Maxwell function itself, you can convert that into multiply with 1 AMU.
Here itself, like that. Are you saying?
No. Before this return function, you convert m equal to m into that 1 AMU, whatever. Now, is it available in SciPy? Then you can directly put.
I'm not sure. It is
Okay.
27, right?
Yes.
This
is approximate value. Fine.
Should I take exact value?
No, let it be approximate is fine. Because we are not even considering the we are only saying 28 AMU, but it is not 28 point whatever. So that approximation should be fine.
Yeah,
1.67377.
67377. Okay, so now we can put values in AMU. So Maxwell, let's say for our initial, we'll take the maximum value of velocity. For nitrogen, how much is AMU? 14, I think.
28. At molecule, it will be 28.
28. And let's say temperature 300. Let's see if we get that works. Now plotting it. So our u should be p dot length space. We have to take velocity values from 100 to 1000 meter per second. Let's take, say, 1000 values. And our temperatures are 250, 300, and 500. Our masses are for nitrogen we have 28 atomic mass in it. For hydrogen we have 2. For CO2 we have
44.
16,
44.
48,
44.
44. So we have to remember the order here. It's nitrogen, hydrogen, and CO2. So masses are done. We have defined functions. Let's make an empty list of Fn values. So how much we have to create same number
Your
of lists
screen
as
is
many
not getting
temperatures we
refreshed.
have. What are you? What is visible right now?
Mass equal to 28,2.
Okay. Is it updating now? Still not updating.
No, I mean, let others answer because I don't know whether it is.
No, it's not updating. Yeah, it's
Now it got
updating.
updated.
Okay. So is the Fn visible? What I have typed?
Yes, visible now.
Yes, it is
Yeah.
visible.
So it will create same number of lists in Fn as many temperature values we have. So it will create 3 lists. So Fn0, Fn1, and Fn2 will be our 3 lists. So for I in our range of, forget n always, for I in range, I in range length of, sorry,
It's not updating, sir.
okay, so it's my internet then. Uh, okay, so let me know when it updates. I'll go slow for a while. My voice is audible, right? Even if the screen is not updating.
Yes, sir.
Yes, yes. Voice
Okay.
is audible.
So now has it updated?
FNI.
Yeah. So we'll append our Maxwell function. We'll call here our function max, which will take the values of u with the index j, because that will go u. And we'll take our mass, which is for nitrogen is, and we'll take our temperature, which would be our index I, because that is in the length of t. So this will create 3 lists of functions at 3 different temperatures. Now I can proceed to plot. So figure size say 10, 5. Can add dpi if you want. So now we have plt.plot u fn and first index. So what this is for our 250 Kelvin. And similarly, we can plot all the temperatures in same graph. Let me just copy paste this. Oh, sorry.
It's not updating.
For a while. Let me know when it updates to when you see 3 plt.plots.
PLT.plot UFN or UF?
UFN, because FN I have appended, right?
No, but
FN is
you have
our
written
list.
UF.
No, it is FN.
Oh, okay.
Maybe,
It's
sir,
not
in our
refreshed.
screen it is not updated yet.
Okay, that's a lot of lag. Let me know when
Yes,
all of
yes.
these
They
3
got, all
values
of
are
them got
visible to you.
updated now.
Okay, cool. So this is for 250 and this is for 500. These are our 3 plots. Now that I have added label, I will also add legend so that we can see. And I'll also add title because we'll plot for hydrogen. carbon dioxide too. So this nitrogen. Now on X label, Y label, you have to remember, I won't write to save time. X label is our velocity and Y is our at that velocity. So
Yeah.
I'll just plot this.
Fraction.
Let's run. This is the fraction. So this many fraction of molecules have that velocity at that temperature. It's plot for nitrogen.
Okay.
Is the plot visible?
Yes, yes, it is visible. Why is it starting below 100?
Below 100. No, this is 100, right?
Okay, I mean,
The
okay,
X
the
ticks,
X
we'll
is,
have to adjust that start from
it
100.
is not 0, 0, 0. Okay.
Yeah. We can adjust the scales and limits, and
You can
because
put
this
X ticks
is
for every 100.
Jigar, would you check the syntax for this?
What is it?
I'm not sure this will work. For X ticks, what are the arguments?
Actually, it is
Fixed
not
value of
refreshed.
x-axis.
Your graph is still visible.
plt.xticks.
I'm not able to understand what is the issue.
So there is a suggestion that you may stop presenting and then present again.
Okay. I've stopped presenting now.
Now you
So
present again. And while presenting, you present only tab.
I'm not getting any such option. It's just your entire screen.
No, when you are presenting, you don't get option down.
No.
Just stop presenting.
See.
Just stop presenting.
Yeah.
And now when you click on present now, you may get 2, 3.
I'm getting only one option, your entire screen.
Okay, okay.
I don't know why.
Which browser are you using?
Okay, that might be this is Safari. This is not Chrome.
Okay, okay, fine.
Yeah. So now is the plot visible?
Yes.
Okay, let me just quickly check if.
Yeah, now we can see your matplotlib.
Yeah, I'm checking the syntax, how they have put xticks. Oh, okay. Okay. Let me try. Hundred to 1,000 in steps of 100. Yeah. So this starts from 100 and.
Yes. Good. It is good.
Okay, so shall I show for hydrogen and quickly, or?
Yeah, you can. If you can. Now the whole idea is you can quickly do all these
Yeah,
things.
I can just copy paste and I can show you. Yeah.
You don't need to copy paste everything.
In Fn is equal to why have we put an empty list there?
This thing, are you asking?
Yes, sir.
Okay, so what this line does is, so we have 3 different temperatures, right? So our functions, our Maxwell function values, we need for each of the temperatures. So what we do is we create 3 lists inside one common list. So what this will do is this will that many number of empty lists. So this says that lists for I in range length of t. Our length of t is 0, 1 and 2. So basically it will create 3 lists for each of the temperature. So it will create so fn0 will be our one list, which is our first element, and similarly fn1 and 2. Is that clear? It will create 3 such lists. So now we can call this via index in this. So it will append fn0 in first list it will append values for temp T0, which is for 250 Kelvin, like that.
So here itself you write
So
mass
we
1 and you should get plot for hydrogen.
here itself I should
Mass index 1. You already defined mass.
yes, yeah.
And it's
If
just
I
that
do that, then
title
I'll
will become hydrogen.
hydrogen.
Maybe you could have defined array for labels also.
I could have done that.
The titles.
Okay, but yeah. So now this is for hydrogen.
Yeah, right.
And if we change mass to 2, and this is for
Carbon
carbon
dioxide.
dioxide. Yeah. This is for carbon dioxide.
Yes, good.
Nitrogen look very similar, just carbon dioxide is shifted a bit towards left.
Sir,
Yeah.
sir, maybe plotting hydrogen will help because for we have as plot in Excel, we see hydrogen's graph was just in ascending, not descending, and we may know
What do you
reason
mean
why.
by just rising?
Yes, peak is
Yeah,
lying
this is
outside
Yes.
yeah, okay.
1000.
So this is for hydrogen. This is for hydrogen. If we want peak, then we'll have to increase the U. Let's say 10,000, and then we'll have to increase this to. Let's see if it fits. Yeah. Okay, the numbers are not visible. And I don't know what is this it's printing.
You are not audible clearly.
Hello.
Yeah, now you are audible.
Yeah. So this is for hydrogen. I increased the velocity limits to 10,000.
Yes, good. Yeah.
So yeah, that's so assignment 3 is done, and assignment 2 first two questions are done. The assignment 2 first question is just Plancker with lambda, so you can try that as an assignment, trying to define that function and plot.
Yeah, in place of
That is
Maxwell
energy in
or
terms
other
of
function, you
wavelength
can.
instead of frequency. Sorry?
So basically, it is just plotting a function.
Yeah.
In place of frequency, now lambda is given.
Yeah,
So
exactly.
functional nature has changed.
Yeah.
That's it.
The plot will look same. It will be exactly the same. Then the second question is also done, and so third question I have not yet done, and
Which one?
fourth there is
Which is
some
the
error.
third one?
The Helmholtz coil. I have yet to do it.
Okay, that is fine. And fourth one?
And wave packet, there is some issue in my code.
Yeah, you can
Should
plot.
I?
You can start plotting wave packet. That should be.
Okay, I'll quickly do it because even Jigar has to show the logistic map.
See, first you
Oh,
define.
already.
First you define what all things you need to plot that. Okay.
Yeah.
So
So
you will
X is
suppose you want 25 different frequencies to be added together. So you will need 25 different arrays. Okay, and you will
I
need an
have
array
done that.
for x value. Yeah, so -5 to +5 and maybe 1000.
I took 1,000 values.
Yeah.
So now I defined Y, and I made as many empty lists. So basically I'm making this columns. So for I in range length of X. Sorry.
Not
I'm
length
making
of x.
these are columns,
You
right?
need
So I need 25 columns.
25
Yeah.
columns.
So for I in range 25. So this will create 25 columns. And now I need one extra column to add my summation terms. So I'll make that as many empty lists as
No, why are you doing that? Why are you doing that?
Because I have to add
But
the
you will need
horizontal.
the length of x. You will need.
Yeah, length of x. Yeah, that's what I was doing. So for j
No, but
in
you only need one. You only need one.
Only one column.
You need only one column.
okay, so that's what I was doing this mistake. Okay, so summation is only one column, which is the sum of the horizontal rows,
Correct.
right?
Correct.
Okay, let's start plotting
So
then.
no, you have to now loop. Write a loop.
Yeah. So for I in range of length of y first,
Yeah.
and for j in range length of x, what to do
Right.
is we have to append the yth of cos of x jth value plus
Y plus
I
y plus
into.
y plus.
Sir, you have in the question you have put that one frequency factor 1 plus 24x01 like that, the last one. So I will be the index, xj will be the value, and multiplied by df.
But why here? You are defining 25 columns. For each column, you are only taking that x of j with that frequency. So it is I into j, and I has to start from with 1. No, you don't have to do all this. No, you just have to plot. Okay, I is starting from what number to
0
what number?
0 to 24 it will
Okay,
be.
we don't want 0 to 24. What we want is we want 1 and every increment with 0.1. Okay, so here you will have to define, you will have to write that. So I mean np cos x j multiplied with 1 plus 0.1 I.
That's what I was writing.
No, inside x, uh, inside x along with j.
Along with index.
Yes.
Oh, okay. 1
J. What is
into
j? J is your angle.
x element.
So j is your
Yeah,
angle.
angle exactly.
So
Yeah. So j plus 1 into whatever the df is.
correct.
Into, you said
No,
one more
not
term.
1 into df. 1 j plus 1 plus I into df.
Okay. I into df.
Yes.
Okay, so now I have y values here. Okay. So now I can do in this loop itself. So I have to add for y. So
Yes,
summation dot append. What will I have to append?
No, what happened? What happened? You complete. Let this get completed. Then you write another for maybe
Another for loop.
and in that you will say, oh no, see for example, for every I, the summation should contain the addition of all x values.
Okay, so for k in range of length of y, what we have to do is.
Oh yeah, now you have to add rows.
Yeah, exactly. So y of 0, 0 will give me first row, first element. So I have to add y of 0, 0 plus 0, 1 plus 0, 2 plus 0, 3 till 0, 2, 4, right?
Till
That
yes,
will be my
yes,
first element of summation.
yes.
So that's why summation dot append. So it will keep adding in that. Summation of append np dot sum y of
K.
y of k will put me, okay, y of k is 0. I'll have to put one more for loop.
No, why one more for? All rows
This
you
will,
are calculating.
so this will give
All
me only
entire row you are adding. 25 numbers you are adding into the first place of summation.
y of k. So it should come inside this loop, right? For j.
See, you are going to write now a loop which will run 25 times.
This is the loop. This will run 25
Okay.
times.
And every time, for it is the other way. You have to write a loop which will run 1,000 times.
Yeah, exactly. So this should be in length x.
Yeah.
Then it should run 25 times. Why is
And
it?
add, do the summation,
Yeah,
and put that
for
in
L in range
summation.
of 25. I have to put summation dot append np dot sum y of L.
Summation
This
k
will
should have
k.
addition of all the numbers.
This should work, right?
No, I don't know. It will go on appending. We don't want that. Why are you writing summation dot append?
This will add
We
some
want
of
summation k.
the
We want summation k.
elements.
We want summation k equal to summation of all y k's.
Okay. Equals to summation of all y
Not
and
append.
k.
Not append. No. I don't know
Let
whether
me see
LK is
if
correct order or KL is correct order.
LK should be correct, right? Because if when L is 0, okay, wait, it should be KL. When K is 0, it should add all L's. Okay, it should be KL. When K is 0, it will go from L0, 1, 2, 3 to 25, put in summation of K, which is, okay, this should work. So now we have summation K and we have to plot against
X.
X comma summation. This should work. What invalid syntax? K length X. Here.
You have missed one bracket in the previous for loop. Y I dot append. How?
Okay,
Yes.
okay. Unmatched. It is matched. Cos.
Sir, there is an extra bracket, I think, in summation k line.
It is highlighted. Okay, thank you. One more. Okay, it is not accepting this thing. because I is index, so it can't multiply with a float. Floating indexes don't exist. So, sir, I think this should work.
Okay. Yeah.
Now where? Okay, one more bracket.
No, why 1 plus? So what is
So we have to increase the value of I after this, right?
We have to say cos x plus whatever whatever will be the dx into x, right?
So this would be the first value. After this, I should be incremented.
It will
xj you
increment
multiply.
automatically. It's for
Xj you
for.
multiply with 1 plus df into I.
Oh, xj multiplied by this.
Yes.
Out of range summation k. This was it out of range?
Why don't you define dimension right in the beginning for summation? So you define 25.
25 won't be the dimension. It should be 1 into. It should be just 1000.
No,
It will have
1000.
1000 values.
Yeah, so NP empty 1000 you can do.
Okay, we'll figure this out later. Should we let Jiga take over and show logistic map? This will take time, I think, to debug.
Okay,
If that's okay.
let bigger take over.
So yeah, we'll provide the assignment solution. The questions which were based for Excel, we did it in Python. So we'll provide
Yeah,
that to you on Google Classroom.
we'll provide it the one entire notebook of all the Excel assignments in Python.
Yeah. So yes, let me start by sharing the screen. Okay. Right. Right. Can you see the screen?
Yeah,
Yes.
Should I zoom in more? Is that okay?
that's fine.
Okay. Yeah. So right. So I think right. I'll just have to rush thoda quickly. Okay. So this topic is mainly based on logistic equation, bifurcation diagram, and yeah, I would like you to be ready with your new notebooks and maybe code alongside. All right. So is everyone ready? Should I start?
Yes.
Okay. So yeah. So so let's say we write this down first. Say x is equal to LaTeX format, and then x is equal to times we want x minus 1. Okay, so this is like the simplest example of, okay, wait, let me just and n here. So yes, so this is the simplest case of population sizes. Say for example, so x here represents the population and r represents the growth rate. And say for example, we take the population of rabbits. Say the first month, say x0, that is uh, when n is equal to 1. So when x0, that is your first month population, say that is 2. And if the growth rate is 2, that means the next year, the next month population would be 4. So on and so forth. So it just keeps on increasing until you get like the population of rabbits to be extremely large. So you can, if you want to restrict the population to some point, you can multiply with this element. Say for example, uh, this item called, okay, let me just copy this thing. Control C, Control V. But now we put this element, the item, which says n minus 1. Yeah. So, okay. So the term 1 minus xn, where x now represents the percentage of the population. So 1 here I have considered to be the maximum percentage, and xn would vary from 0 to 1. So let me just give a graph of how xn varies with xn minus 1. So let me just import matplotlib dot pyplot as plt, import numpy as np, and I run this cell. In the next cell, I try to define this logistic function, which is the same as the equation I have given the explanation of. So that will take r value and x value, and it will return, say, r times x 1 minus x. Okay. Okay. So creating a next cell, I'll say x is ranging from np line space. It'll range from 0 to 1, and in the steps of say 1000 for now. And plt dot plot x and logistic the function, and say r ka value is 2 and x is just your x, that array. And say we provide x label as this value. So this will be x n minus 1, and plt dot y label will be x n. Okay, right. So let's just plot and see what we get. Right. So as you can see, as xn minus 1 increases, so xn just represents the previous month population, and this would represent the present month population. So if, say for example, xn minus 1 increases, then the element, the item we input 1 minus x as, it will decrease the next month population. So it's kind of a negative feedback loop. Okay. So yeah, let's just create a different plot which takes the same function, and say I have the initial population of 40% of the maximum, so 0.4, and r is equal to say 1.2. Okay, and then this I'll just create this x value list, which will be useful later, as well as the logistic value list. So yes, the time list as well. And for plotting purposes, I'll just make this as 40. You'll see the use of it later. And here comes the for loop. So in the for loop, you have say 40 for now. And so that means, I mean, this what this means is the number of measurements you make. So if if you're measuring the population 1 month, so this will be 40 months. Yeah, so x values would be, sorry, x values would be appended by x, and logistic values would be appended by the logistic sorry logistic value of given r and x. Okay, so now x is equal to we update x such that it takes value of the previous x value, so that is logistic values. Yeah, and then we append time, which is I, and if I is just a break limit, so that if time is maximum, then the graph won't run out of boundaries. PLT dot plot time x values, PLT dot x label time, PLT dot y label population, and PLT dot x lim 0 to say x limit. We have already defined x limit as 40, so it will be 40 months. And PLT dot y limit would be from 0 to 1. So we're plotting population in the y-axis, and then we do PLT dot show. Okay. So as you can see, if right, so from this equation, let me just copy this equation and then print it. Right. So this equation, if r is say, let's say if r is 1. So after some point of time, the population will die out immediately, because since I mean 1 times the previous month population will just give the previous month population also multiplied with this term, and this is a negative feedback loop, so it will just decrease the value of r times x. So the population dies out with increasing time. Say for example r is 2.5, so the growth rate is 2.5, and you can see that the population after some increase in population, the population just stabilizes itself. You can check for say r is equal to 2.7. You can do similar thing. It will kind of fluctuate a little bit, but after few months, the population will stable out. And see for 2.8, it will fluctuate even more, but at the end, the population will stable out. Now, if we say 2.9, the fluctuation will increase, but eventually you will get a stable population. But if now say r is equal to 3, the population will not be stable, and it will just keep varying between two population sizes. So you can just verify that if you have a bigger number, say 400. Oh, right. 400. What is the issue? I think Is it not plotting?
It will plot only up to 4.
No, the R value is not changing in this graph. Only I have defined time as x-axis and population as y-axis. So time variable is I. Then I should be this, but at the same time, okay, yeah, yes, should remove this thing. Let's say this, yeah, this will work. You can see the population is still keeping the fluctuation even after 400 months. So you can
What is the value of R you have taken?
R have taken as 3.
Okay, therefore it is fluctuating between 2 values.
That's correct.
Take R as 2.9.
I'll just decrease the size of the graph. So if we have a clear.
Don't decrease the size. Just make R as 2.9. But so now it is converging to one population.
Yes.
You can make it R as 2.8 or R as 2.8. Yeah, it will converge fast.
Yes.
And you can, instead of plotting, you plot scatter.
Okay.
Sir, I am getting an error showing that name logistic value is not defined.
Logistic values. Acha, we have to define a list, empty list first, and then append the logistic values. So you
Yes,
must
sir, I
have.
am doing that, but still getting the error.
Have you made sure that there is S after value?
Yes, sir.
Okay. You can share your doubt on WhatsApp. I think Pratik will be able to help you.
Okay, sir.
Okay.
Yeah, post a picture with your code and comment.
All right. So you can just play around with this code and have many values. You can experiment with many values of R. Say, let me just decrease this just for purposes. Line not defined. Okay. Again. So now if I have R value as more than 3. So let's set this, and it will keep on varying between, I think it is just 2 population sizes for R value 3.2. But if you come to R value 3.54, what you get is, I think, a number of population sizes. So I think 1, 2, 3, and 4. Yeah. So there are 4
You
population
can see
sizes.
this better if you plot scatter.
Okay. Let me try that.
Just make it smaller point.
Right. So okay. Size is equal to 0.5. Okay, too small. Still too small.
Yeah. You can make it 1. S equal to 1.
Yeah.
Basically 4 populations.
So one can play around with the value of R and see what you find out. There is
Go
sir,
to
should I cut?
3.6. Go to 3.6 and you may get 8 values.
Okay. Think
do not look at the initial iterations. In fact, what I suggest is
okay,
first
yeah.
500 iterations you just kill and later you print.
All right. So let me just. I'll take the values from 300 to 400. 300 and then 300 and this. So I can have, yeah, yes.
Actually, it is going still higher, but is it plotting correctly?
If I line plot it, then let's see if the lines are fit.
No. Yes.
Oh, okay. So I'll take a different small range, say 350. Yeah. So this, are you able to see my cursor?
Yes.
Yes.
Okay. So this point and this point is repeated, but so the population size varies. So let's just count 1, 2, 3, 4. Oh, even the below values are there. So is this? I think so. 1, 2, 3, 4,
If you keep the
5,
scatter point, no,
7, 8,
then you can clearly make out
11.
how many rows are coming.
That would be good. Yeah.
What you can do is you can take X limit to say 1000 and print 900 to 1000.
Excellent. Okay.
And then print X limit minus 100. So basically
Yeah.
it is grouped together. The population is grouped.
Yeah.
The population doesn't, you don't get population somewhere in between. They are grouped into this group and this group. And they oscillate between those values only. You can make it 3.55 and see that it has to see that this horizontal line is also slightly fluctuating, which means there are two populations getting generated from this stable line also. Similarly, this line also, the third line also is fluctuating, which means two different populations are generated. Fourth line is also fluctuating. So basically this is 8 cycle. So there are 8 different population numbers which are coming up one after the other.
Yeah.
So period doubling means at 3 it started becoming oscillating between two population, then started oscillating between 4 population, then started oscillating between 8 populations here. So you can go to further 3. What is this? 3.55 it was, right? Make
Yes.
it 3.56, so the difference will increase. And you can clearly make out now that the difference has increased.
Okay.
You can make S equal to 1 then in the scatter.
Yes.
So better to, and you may change the color to red or something, so that.
Okay. Yeah.
Sir. Sir. Sir,
Yes.
excuse me.
Yes.
Sir, this is logistic equation, no? So we can plot population versus growth rate. So we will get a chaotic map.
I'm sorry, I'm not able to hear you.
This is logistic equation, no? So we can plot population versus growth rate graph, and
Yes, yes.
We'll come to that right now.
that is linked to chaos theory.
Yes, yes.
Your voice
So,
is very dim.
no, he said that. Can you hear me?
1 second.
Hello.
Yes.
So he said that can you plot the population versus R? Like R is the rate.
Yes, we can. We'll come to that right now.
Yeah. So what? Okay. One thing that you can do here itself, you can put some random number like not I mean 3.7 or something like that, and see what happens. And you may plot more points. 3.7.
Plot more points in the range. Like just make
Say
it big.
500 to X limit or something. 500 to X limit.
Okay.
Yeah. So points basically get scattered everywhere effectively. Effectively, points are getting scattered everywhere. Okay.
Okay.
So maybe it is becoming period doubling, further doubling and further doubling. But interestingly, there is one particular region where this period doesn't go on just doubling. You can put R equal to 3.82.
82. I think there is some
82. Have you run the?
Yes, I have. This is 3.82.
Okay, 3.84. Yeah. So the population is just converged to 3 populations. Now you don't expect when population goes on doubling, suddenly it turns to only 3 population. So this is called signature of chaos. That period 3 somewhere indicates that surely it has reached a chaos, because population doubling will never take you to period 3 like this. Now you can go for that population versus R.
Okay. Right. So yes. I'm sorry, I'm not able to hear you properly.
Sir, what value of R?
Mona, there is a lot of disturbance from your system. You may remove the headphone or just check that. There is a lot of noise from your system. You can continue, Jigar. She will type the.
Yeah. So yes. So now say we have the value of R ranging from length is. It will range from say 2 or say 0, and it will go to 3.99, and it will go with the yes, I haven't defined iteration, so let me just define that right now. Iteration is equal to say 10,000. Okay, and yes, so now we already have defined the logistic function, so we will just define the figure size. And, size, and that will be 15 by 9. And say DPI wanted as 600. And then as we have seen earlier, we'll make empty list for x values, y values, and run a for loop for every element in R. So I would now represent each R value in the loop, and x values should be appended with R, because we are plotting R values on x axis. So x values will be plotted on x axis, and similarly now we update x with say some random so x will now have any random value from 0 to 1, and say for I in, or say for j in range, okay, for now we'll say 5. So for each r value, we'll run 5 iterations of x. So logistic I and x. And then y values dot append. We print the values of we append the values of x, that is our population, in the y-axis. So y values. So now we do plt dot scatter, and then x values, y values. I'll choose the color as black, marker as a point, and what else? Say line width is equal to 1, and size is equal to that also 1. So yes, there will be, yeah. So okay, now what we do is set the x limit, plt dot x limit, and these limits come go to the first element of r to the, say, around last element of r, and yes. So now plt dot ylim, and this will be from, say, uh, let's just say it's from 0 -0.05, or just say 0, doesn't matter. Okay. And it will go from, will go to 1. plt dot title bifurcation, oh, bifurcation diagram, and plt dot next label is x population, plt dot y label. So no, sorry, this will be this. Yes, okay, and this will be that is your growth rate. So now if you plt dot show, okay, keep a note that I have only taken 5 iterations for the for updating x values. So we'll see why it is important. So I think yes. So now we get a graph like this, and you can see it's very scattered and everything, and it's not a proper logistic diagram. So if we increase the value of iterations for each r and see what we get. So it's become more and more defined, and you can see that for, okay, can you see this? Is the screen updated?
Yes.
Okay. So for r value greater than 1, we see an increase in population. Since we have seen here that, where is it? I think this one, yeah. So if we keep r value as 1, the okay, let me just keep it 40, 0. So you can see it slowly declines, and this is what we see here as well. So if r value is, I mean, if r value is greater than say 1, then this is what we get. So let's say 2. So it will be a stable, population, and we can see that by checking when r is equal to 2 and the population is 0.5, around 0.5. And this is what we observe here. it will be stable at 0.5% of population value. You can check this, and then we see here that at r is equal to 3, the population diverges to two population sizes. So we can confirm by just doing, say, r is equal to 3.1, and here you can see there are two population sizes varying. And yeah, so if you want a more precise diagram, you can just say I have made this to 1000, and I'll also increase the iteration, say to let's see 100,000. So it may take some time, depends on your device, but it will give you a good output. So I mean, if you have any doubts, let me know till this runs.
Can you just summarize once what you have done? Like this?
Okay, for this code.
Oh, yes, sir.
Okay, so here I have defined the figure and fixed size and the dots per inch. Here I have created two empty lists which will be useful in the for loop. And on the this x values will be plotted on the x-axis, but it will have the values of r. So I have run the loop to take the values in r. So r is ranging from 0 to 3.99, right? So it will just take values between that and then keep each values in I. So it will append this append I. It will append x values with the value I, and then okay. So we have seen, okay, yeah. So this is the. Can you see this clearly?
Yes, sir.
Right. So you can see that at I think 3.84, as sir mentioned, you are getting three values here as well. So let's just verify that. Okay, let me just make this and say that we want to take a value from 2. If all goes well, this will work out. And where was I? Yeah. So X is just a random population size right now, which will be ranging from 0 to 1. And then for J in range 1000, it will iterate X value for each R 10,000 times. And then it will update the X value. Now this updated X value will now go to the list called Y values, which will be printed on the which will be plotted on the y-axis. And once you scatter plot it, you get a result like this. So you can see there's a conversion between like there's conversion here, there's conversion here, and there's conversion here. And this R value would be 3.84. Let's check that here.
Rohit has raised the hand.
Okay. Let me see. Yes, Rohit.
Uh, Sir, I wanted to ask where exactly that scattering region we can we get that actual part where we get bifurcation here on program?
After 3.
Okay,
Yeah,
after
means
3.
what is that exact?
So you mean this point or these points?
The first and the second both.
Okay,
I
okay.
want
So
to
we
know
can
how.
do that by telling the np.linespace function to give us value between 3 and 3.99, and that will be done in, so there will be 1000 elements between 3 and 3.99 with r as the variable. So we can just plot that and see.
So both the first and second order, yes, yes. That's what I wanted to know. So higher order bifurcations are also visible. So thank you
Yes,
so much.
that's correct. And
Yes.
if you want to play with, I mean, zoom in a little bit more, you can set the size of the scatter plot to be even smaller, and you may get and increase the DPI size. So maybe 1,800 or so.
Okay, what I
So you may,
suggest, you make iterations 1,000 only. You don't need to go because we are not able to see that. And
okay.
in J in range, you are writing 1,000, no? That
Yes.
you can increase to maybe 2,000, 5,000.
Okay.
कुठे आज येतं त्या दिवशी कालच धावलो.
Rohit mic.
Okay, are you able to see the scatter plot? I'll just increase the size a bit.
Yes.
Yeah. So say 5. Hopefully, this will give us better results. Yes. Now, is it visible?
Yes, it is visible.
All right. Yeah. So I think this is what I wanted to include in this logistic map. So this is the bifurcation diagram. You can, if you have followed this tutorial, then you can play around with the values and see what you get. I think, let me check. Yeah, I think that's all.
So increasing DPI and iterations will give you a more good looking bifurcation plot, but it will take some time. So as
It will, yes, it will take a lot of time.
actually a lot of time.
Yes, so we would suggest that you don't go for iterations higher than 1 million because it will take a lot of time.
Yeah.
Yeah.
So by experience, 10 million takes about 2 hours. So keep it below 1 million.
Yeah.
And also, what is useful is you don't plot all because initially some population, I mean, some generations the population is going to fluctuate, and it will settle after some time. Yeah. So,
Maybe.
so that's fine. Here it is fine. You made.
Okay. I mean, yes. Any more questions? I'll be able to answer them.
What we can do is now we can stop. People can ask questions on the group, and one assignment ma'am has given that people have to work, which can be discussed in another 2 days. But first, that choral problem which is given to you, that you have to that they have to solve first.
Okay. Yeah.
Also, sir, I would like to point it out. There are the fifth assignment in the finding mean, mode, and median. From question 8, there are so many values. You see.
Yes, yes.
So, do we have to write that manually? How we are going to do
No,
that
no.
in
You
Excel?
copy that in the Excel sheet. Copy that entire table in the Excel sheet, and then Excel will do it.
But okay,
Yeah, you
The
can
table can be copied into Excel sheet.
you can copy it and paste it as values only. So it will put values there. So paste special option you have to use.
Okay.
I think that will do.